Alright, here we go. We're going to do simplifying radicals, really simplifying square roots, part 2. We're going to, today you will learn to utilize various methods to simplify radicals that involve division. Okay, how can we do this? Let's get to it! Okay, so for this lesson, what I'm going to do is I'm going to focus on how you see it in your notes and your assignments. So we'll approach some very basic stuff. And then a little bit more complicated, what do you do in this type of situation, to finally end with how you most likely will see this in geometry. So where do we start? Well, let's start with this. Like if you see something like square root of 9, you know that's 3. Or square root of 25, you know that's 5. Okay, so what if I do something like square root of 9 over square root of 25? Well, guess what? You can take the square root of both numbers, and that's 3/5. So, like, if you see something like this, and keep in mind, you have something like this, then you can join those two together, take the square roots of each one of them separately, and say that's 3/5. Give me a second here, because apparently my dog decided he needs attention, or he wants to be in the show. So, the first thing I would look for is see if you can say, take the square root of the number, of each number individually. Like here, square root of 25 over 4. Well, the square root of 25 is 5. The square root of 4 is 2. Trust me, if you can take those square roots separately, hopefully that, well, not hopefully, that should be simplified. Alright, so what happens if we get into something a little bit more difficult? Let's say you get something like this, square root of 10 over square root of 45. Okay, if you look on the, like, if you were to look at your perfect squares, these are not perfect squares. So what do you need to do first? Well, you need to simplify that fraction. So what I would do is simplify 10 over 45. Okay, don't worry about the square, just simplify that. Remember, if you type this in our TI Inspire calculators, it'll automatically simplify the fraction for you. But both numbers are divisible by 5, and that would give you 2 over 9. So notice how I separated those two. Is there a square root of 2? No, there is not. Is there a square root of 9? Yes, there is. Just 3. And that's what you want to see. You cannot have a fraction, or you cannot have a radical in the denominator, and that's what we're going to eventually lead up to. So what about this? 10, square root of 10 over square root of 2. Well, 10 is divisible by 2, and that would give you square root of 5. And that's it. I mean, so you can divide these two numbers because they're both under the square root symbol. So you're technically allowed to do that because it's like saying something like this, 10 over 2. Okay? And then that would lead you back to that. So you should be able to do something like that. Now, again, if you get something a little bit more difficult, say, here's one, square root of 10. This computer chose a lot of square root of 10s. Over 125. You should get something like square root of 2 over 25. Like you would get 2 over 25. Like I said, you're typing in, actually let me put it this way, you're typing in 10 over 125 in your calculator, and that gets you 2 over 25. Okay, well, again, there is no square root of 2, but there is a square root of 25, which is 5, and you're okay. So what happens if I have some numbers in front? Let's find out. So here's an example. What I would do on this one again is go ahead, work with this part first. Okay, so 5 over 45, if I simplify 5 over 45, I get 1/9. So that means here what I've got is 5 times the square root of 1 over 4 times the square root of 9, which square root of 1 is 1, so that's 5. 5 times 1 is 1. This would be 3, and I would say 4 times 3 is 12. And so I would get an answer of 5/12. Okay, so now we have something like this. 4 square root of 20 over 3 square root of 4. And again, focus on this part right here and say, okay, look, 20 divided by 4 is 5. Remember, if that's bigger, it's going to go up here. So this would be 4 square root of 5 over, say, 3 times 1 or whatever you want to put. And that's it, because again, you have it's okay to have a regular number on the bottom. That's fine. So again, that should hopefully answer those. Now, where is this again leading up to? Okay, so one more example like this, and let's see what happens when I have like 8 and 50. Okay, again, I would type in 8 divided by 50 on my calculator if you have problems simplifying that on your own. But that should get you 4. Okay, remember, 4 and 5 are going to stay there. Okay, so that would get you 4 over 25. So that would be square root of 4, square root of 25. Okay, well again, what's the square root of 4? That is 2. So that would give me 4 times 2. What's the square root of 25? That is 5. That's 5 times 5. And that would give me 8 over 25. Really coincidental. And that should do that. I mean, that is it right there. Okay, so what is this all leading to? This is leading to what's called rationalizing. We cannot allow a radical, a square root, or any type of radical actually to remain in the denominator. It's just kind of like one of those written rules or unwritten rules we're not supposed to do. Okay, so what happens, and let's start off with one that we can't simplify at all. Let's say we have, I'll start off with something simple. 5 over the square root of 2. There's nothing I can do about that. And see, we're going to get a lot of square root of 2s, square root of 3s. That's why I'm going over this, especially with the trigonometry stuff. So how do you rationalize this? Well, the way to do that is you multiply both top and bottom by whatever is the square root on the bottom. So in this case, 2 times 2, or square root of 2 times square root of 2. Now what happens here is when you multiply by its opposite like that, it gets rid of this square root. So here, square root of 2, square root of 2, that means you have a pair of 2's, and that leaves you with just a 2. These two you can't do anything with, so you just put them together. Remember, you can only multiply a square root and a number if both numbers are under the square root. If they're one's out, one's in, then you got to put them together. Okay? Let's say you had 7 and square root of 3. Again, this is what we're going to mostly work with in geometry, square root of 3. Square root of 3, square root of 3, 7, square root of 3 over to 3. That's it. It's fairly simple. Okay? So how do I make this a little bit more difficult? Let's say you had, well, weirdly, I don't think it would be possible, but let's say you ended up with something like square root of 21 over, say, square root of 2. Okay, you try typing those in, you would get 21 over 2. It doesn't simplify. So then again, to rationalize this, you say square root of 2, square root of 2, and then you could go, okay, 2 times 21 is 42, which, by the way, if 21 is simple, well, I'll go over that later. And this would be 2, okay, and that would hopefully be it. Now, again, I would hope that you would check to make sure that 42 cannot be further simplified. Let's see, that's 2 and 21. 3 and 7. There's no pairs, so yeah, that's your final answer. Okay, that is what this really is trying to lead you up to eventually. Okay, is that we should be able to rationalize and try to put those together. I will try to make sure you have some problems for this, and we'll kind of go from there. But I'm going to go ahead and stop there for now, and thank you so much for your time, and y'all take care.